starting in a few minutes, ladies and gentlemen. Ladies and gentlemen, a very warm welcome to the Swiss Pavilion. My name is Dante Larini. I'm a project manager here. And today we have a real treat. We're going to speak about space debris. As you know, space debris is a big problem that we're facing. We have over 1 million items which are in orbit, and it's getting worse and worse. And so today we're very pleased to be speaking about this in more precision. Before we start, I would like to salute and greet our guests of honor. We have the honor of having Minister Marcos Pontes, of former Brazilian astronaut and minister, who is with us today with this delegation. Thank you very much, Mr. Pontes, for being with us. We also have our very own astronaut, Professor Claude Nicolier, who is with us today and is a guest to this. So it's such an honor for us to have two leading figures of space to be present in one of these events. A bit, as you can see from the logo there, SwissNext is an organization of the Swiss Secretariat of Education, Research, Innovation. And our job is to not only promote Swiss education, research, and innovation abroad, but also connect them with local equivalents. And this is what we're doing here at Expo. This is what we're going to do for the 6 months. We try and connect Swiss actors, universities, startups with their equivalents from the UAE, the wider region, and the world. So I think it's time to go straight into it. We are very pleased to have Mr. Luc Piguet and Mrs. Emmanuelle David, who will be animating the session today. So without further ado, Emmanuelle, the floor is yours.
So welcome everyone today, and also a warm welcome to our online guests. So the economic growth of the space sector goes hand in hand with the need to keep the environment sustainable and also allowing a fair and equitable use for the outer space. And this raises questions around sustainability that is at the core of these numerous discussions and debates that we're going to have today. At this object from space. And this led to the creation of Clear Space, which is represented today here. So I'm very glad today to introduce our panel of experts that will explain the current situation, thanks to debris observation, and what is needed to improve the situation from also a technological point of view, but also from a knowledge creation, meaning observation and data-based creation to problem solving, such as the Clear Space 1 mission. We'll also talk about metrics about space sustainability. First, I would like to introduce Thomas Schilneck from the University of Bern. So Thomas, can you talk us about the activities that you've been performing about space debris observation? And according to you, what are the current and next technological breakthrough in the domain? And which impact do you expect from this breakthrough?
Thank you, Emmanuelle. And thank you very much for having invited me to that panel and giving me the opportunity to explain a little bit what we are doing and why we are thinking that observations are the key in this game. So let's remember that observations actually are at the foundation of everything we are going to talk today about. So it's really the basic we need, and you can only know what you have been observing, as my dear friend Moriba would say. So we want to gain our information finally, but the type of information you want to have is very much depending on who you are and what you are doing. So if you are operating an asset out in space, a spacecraft, you are most concerned about safety of flight. So you would like to do the best in terms of avoiding collisions. So you want to know you want to know the orbits of the objects out there very precisely or very accurately. If you are a spacecraft designer, you're more interested in the overall risk you face, even from small size objects. So you don't need the, let's say, catalogs of orbits, but you need more information about the risk from perhaps small size objects in order to shield or passively shield, mitigate the risk. If you are a government or a space agency, or let's say a scientist, as I am, you are more interested perhaps in the long-term sustainable use of space. You want to know how is this going to evolve? How can I protect vital space services for our society? So, given your answers on how and what you would like to observe, at first glance, you'll probably say, hey, there is this nice catalogs of orbits out there. So why do we need more information? I mean, apart from keeping these orbits accurate, that's all what we need, because then we can avoid collisions and everything is fine. So each and every orbital catalog we have out there is just a small part of the full truth for many reasons. First of all, that catalog might be not the full truth in the sense that some of their observations there were wrong, or some of the, let's say, attributions between orbits or objects and objects in the catalogs and observations were wrong, whatever, And secondly, because each and every of this catalog is incomplete. And today I can tell you it's by a high degree incomplete. And the third reason is, once you have a catalog and you keep just maintaining these orbits, you will miss any type of events which may happen in space. I mean, there's many events which are unexpected. For example, we may have, and we had, collisions in space. We probably have quite some collisions which we never observed, really. We may have breakups in space. Some of them we didn't observe at all. We can just guess there must have been something out there. So this brings me to what we are doing. So we are searching for space debris, first of all. If we find some, we are determining their orbits as best as we can, and then we try to characterize them. Why do we need to characterize them? You may also think of space debris being just, abandoned upper stages, dead satellites, and a few other pieces. But by far the most in number are fragments where we don't know really the nature. For many of these fragments, we don't know how they were created. And as long as we don't know the nature, we don't know, we have no handle to efficiently mitigate these kind of fragments, for example. So we need to know sources and sinks, as I call it. So how are they produced? The physics is something we are interested in. How are they created? Of course, if you put up there an object, you create eventually a space debris if you leave it up there. That's a simple explanation, but there is many others. And, things like aging outer surfaces of spacecraft, which shedding pieces here and there. That's just another mechanism which we were kind of not aware for many years. So this is why we also characterize them. And then finally, which is something which is really important, is the evolution. We really want to know how this population of space debris is evolving over time, short time, long time. We need models, and these models need to be fed by observations. This is absolutely key. Even if the observations are only statistical, in the sense we have been seeing so many small objects, we don't know their names, we don't know their orbits, but we have been seeing that there is something out there which needs to be better characterized. So this is what we are doing. We are using telescopes to do that. In my particular observatory, optical telescopes to find them and observe them, determine their orbits. But we also using so-called laser ranging systems. So we send very short laser pulses to these objects and measure the light travel time, and by that we measure the distance. This is a new technique, rather new technique. It's very challenging because only a few photons come back reflected from these objects. It gives us a much higher precision and hopefully finally accuracy for orbit determination. We cannot use these lasers to find objects, but we can refine their orbits in order to ease, let's say, the collision avoidance maneuvers or conjunction assessment procedures. So this is what we are doing. And we are doing this in Switzerland at our observatory with 5 different telescopes, 24/7, really each and every day out. And we also have small network, a worldwide network, together with our colleagues at the DLR, the German Space Agency, and we are operating robotic telescopes at different places in South Africa, in Australia, and very soon one in South America, in order to have access to a worldwide network in order to maintain the orbits, in particular of some of the objects we have been discovering. And Emmanuel, you were also asking me about new technologies and the impact of that. So first of all, I mentioned the laser ranging. That's a new technique which I think has a very good perspective, but we also need additional techniques to be able to measure objects during daytime. In the optical, it's feasible. There is upcoming infrared sensor technologies, infrared imagers, which we could use during daytime. First tests have been done. And I think one thing which is, from my point of view, really important, this is that we try to fuse the hardware of sensors, detectors, let's call it, even the silicon in the sensor, with more artificial intelligence. This is how our eyes, our brain is working, and I think this is going to be key. And I'm very hopeful that we'll have sensors or detectors which have artificial intelligence included. For example, just to give you the idea would be that we don't need to store images of, the sky where 99.99% of the information is not what we are interested in. We need to store the information we are really interested in, the moving object in front of the stars, for example. And this could be done at sensor level. This would be a great breakthrough if you would have that. And finally, something I was working for many years to see it realized, that would be constellations of space-based optical sensors, small size, which would allow us to better understand the small size environment, millimeters to centimeters, which, by the way, are the highest risk for space asset. The highest risk comes from the centimeter pieces, which we don't know at all, or we have no catalog with these objects. So we try to avoid the large pieces. That's fine and necessary, but we need to take care of the smaller ones as well. I think with that, I would stop here and give it back to Emmanuel.
Thank you very much, Thomas, for answering those questions and so explaining us about the work you're doing in building up, also like completing this incomplete catalog, as you mentioned, and also contributing and understanding the evolution of the space debris population. Fascinating also is the new technologies that you mentioned that's going to also help break through also this knowledge gap with laser ranging, also measuring objects during daytime. Also the so new sensors detector that can also use artificial intelligence in order also to sort out the data that we get. And also, of course, to have also space-based observation, which is really critical. So next speakers I'd like to introduce is Moriba Jah, who is a professor at the University of Texas in Austin. Moriba, so you've been working on this great database called Astriagraph in order to gather all this information that astronomers such as Thomas are gathering together. So can you tell us a bit about this database? Who are the users of this information, and what is the impact that you expect to have with Astriagraph?
Yeah, no, thank you very much for that. It's an honor and pleasure to be with everybody, even though remotely, and certainly always an honor to be here with my colleague Thomas. Look, for all the reasons that Thomas outlined, and even more, the idea of having kind of a let's call it a digital commons of information about stuff in space is pretty critical. And so I think one of the things that I'd like to be able to do, if somebody allows me to share my screen, then I can share some stuff with you real quick, because I think a picture is worth 1,000 words kind of stuff. Let me know when you've allowed me to do that, and I'll share my screen.
I think you should be able to share.
I'm sorry?
You should be able to share from what I see here.
No, not yet.
Ah.
But in any case, you know, there's a lot of there's very diverse inquiry that goes into things in space. Everything from the scientists, you know, Thomas told you about, you know, their needs in terms of determining orbits and characterizing the debris and that sort of stuff, to people that are policy type folks, where they need to get policy products out of stuff in space, right? When we want to understand how are people interpreting and implementing different treaties, laws, policies, guidelines, that sort of stuff. I tell people you can't manage what you don't know, and you don't know what you don't measure. And so in a world where a lot of people are saying, oh, well, we don't have enough rules, it's like, well, we actually have a lot of you know, space law, you know, treaties and whatnot, but what we don't really have are the data, the evidence to kind of quantify how people are, you know, interpreting and implementing, you know, these sorts of things. So that's one of the things that we've been working on. I can tell you that, you know, just like you go to, I would say, you know, a library to be able to get information, you know, a library has information for people that have very different needs, right? And so that's kind of what we're doing with Astrograph. It was, you know, funded initially by the FAA, and then you know, the U.S. government through my own contracts has been basically providing some funding to keep things going. But yeah, this is the premise of Astrograph is really a digital commons that allows very different inquiry, everything from some of the things that Thomas was talking about, to even astronomers wanting to quantify light pollution in terms of how do the corrupt, you know, they're a nuisance to their own data and that sort of stuff, to collision, conjunction warning type things. And again, trying to quantify, monitor, and assess how people are interpreting and implementing, different space laws and treaties and that sort of stuff. So that's pretty much what we've been focusing on. We have been collaborating, with Thomas over the years, and one of the things that we've been looking at in terms of technologies are photon counting devices, and Thomas has one of our sensors there. So very much looking forward to seeing, what we can get from this technology, because at the end of the day, you probably can't do much better than counting individual photons, measuring their wave-like properties that are reflected off of objects, because we know that any given photon that we can measure came from a very specific location on that object. And so that there's a lot of power in there. And if we can measure the photons individually, then the burden goes away from the technology and onto our ability to properly interpret these things and unpack the information content of these photons. So I think, in terms of technology, that's where we're going. I fully agree with Thomas in terms of getting some sort of machine learning, augmented intelligence kind of stuff at the sensor as much as possible, like the edge computing aspect of things. That we see a lot of merit in that makes a lot of sense. And okay, so you finally let me show my screen. So okay, so here we go. So hopefully this you can see this sort of thing. A lot of people talk about places to get data. When all you care about is the place to get data, it's kind of like walking into a room with books scattered all over the floor. It's insufficient just to have a glorified Dropbox of places to get data. What you want, instead of just having books scattered all over the floor, because good luck with trying to find what you need in any sort of reasonable amount of time, what you want is something that's curated. You want information that is organized, that is curated, that is accessible. It's in a lingua franca that you can say, hey, I'm interested in this specific thing. I know how to get it, and it's readily accessible to me. So that's one of the things that is important in how we've done Astriagraph. And very quickly here, I can share this. Here is just a visualization. Every single dot is an anthropogenic space object, something that a human is responsible for in one way, shape, or form. And so this thing is something that anybody can kind of access around the globe. I say to people, all these are opinions about stuff in space. It's funny. People think, oh, well, you don't know exactly where things are at. No, we don't. There's uncertainty mired in everything. And to get to Thomas's point, we don't even track all the objects, right? So basically, we only track a small percentage of the problem, because back to what Thomas said about small debris and that sort of thing. And look, from statistics, the population we're interested in is the population of all these anthropogenic space objects. But that is unknowable because we can't measure the whole population. We can only measure samples of these things and then try to draw conclusions about the entire population from the samples. That's part of the challenge. I can also tell you, given that, here's an example of something that we've been doing, which is taking the locations of objects at any given point in time. Here we have like 4,000 of these that we took from Astriagraph in Cartesian space. You can kind of see different, geo and the things there are Leo that you can see there. The color coding is the plane of the orbit with respect to the equator. But here we're looking at different ways to visualize this. Here we're just computing specific orbital angular momentum of these objects, position, cross into velocity. And we can see that in this space, geos are on top, geotransfer orbits are in the middle, low Earth orbit stuff is there at the bottom based on orbital energy, but these things naturally segregate into inclination bands. So you can literally see orbital highways in this space. And it basically affords us another way to kind of do this sort, of analysis. To Thomas's point as well, we have a few remotely operated telescopes, one in Australia, the other one in New Mexico, one in Chile that we just got. You can see the coverage. We don't have anything where people are currently located. That's a gap. But we're trying to finalize our process of getting into SmartNet to join Thomas and those folks and combining these data. So that's something that we're looking forward to. And yeah, you know, the way that we organize information in Astriagraph, basically this gives you kind of a bit of an idea, is that, you know, the inquiry, varied inquiry problems are here on the right-hand side. We can click on one of these bubbles and see what entities need to feed into solving that problem. But then, you know, the information that resides in Astriagraph, you can kind of see what are the data that would actually feed into that specific parameter. And so Astriagraph is kind of this digital commons, digital library that allows varied inquiry to pose interesting questions. Given a multi-sourced information here on the left, we're this middle aspect, right? The knowledge graph database is this middle aspect that takes multi-source information to satisfy a very different set of inquiry for everything from the things that Thomas spoke to again, this idea of, you know, policy related things. One of the things that we were interested in is, you know, are people compliant or not with disposing of their objects at geo? So this is the schema that we developed in this kind of live schema. We've also been able to look at, you know, how people are registering their objects with the United Nations. Not everybody, you know, all these countries sign the same document, but all these countries are also interpreting and implementing these things differently, right? So this is back to trying to get evidence of behavior of how people are interpreting these things. And then I think a last thing I'm going to put here is, you know, we've partnered with IBM and other people to develop this thing called Arcade, which people can get accounts on right now and have access to higher accuracy state vectors on everything in the catalog that most people you know, would want to have a care for. But you can see that we have demos for conjunctions, for light pollution to astronomers, compliance with registry. So again, a common logosphere that can satisfy a very wide and diverse you know, set of inquiry. So with that, I think I'm going to just leave it at that. I think one last thing to show you to get to what Thomas is talking about, right, which is quite different. It's not a policy product, but here we have actual data. You know, the dots are photons that we counted reflected off of this dead satellite Topex that's in LEO, but higher altitudes of LEO. So the problem at hand is, you know, this is a CAD drawing of Topex in the middle. That's not what we observe. We observe the dots. So we're trying to solve this inverse problem of, given these dots that look like this weird star pattern, how can we interpret these dots so that we can recover the thing that's like the CAD model in the middle? That's what we're trying to get to. So with that, I think I'm just going to leave it at there and say, you know, merci beaucoup. Thank you.
Thank you so much, Moriba. So if I may sum up a bit, what you were saying is that, so you're trying to create a digital common information, like a library, like sorting out all this information in the same place. This can be used by scientists that want to better understand space debris population, but also what is the light pollution, and that they can also collaborate together. But other users are also policymakers, so they can also have the evidence and the data, you know, on how people are behaving, so they can take also informed decision. So this is also critical. But also you're looking also, maybe it can be useful for operators that also want to do some collision avoidance maneuvers. So this is really, really interesting. And you also showed us also what can be the future, and also the observation that you're making, and how we can also link this observation to what is the truth. And this is something that you point out, and that Thomas also really raised, is that the data we have is an interpretation of a truth, but we don't know, it's also an interpretation, and this is also important, and we want to get like the closest to this truth. So now that we got two scientists talking to us, so how they create the knowledge, how they want to understand better the space debris population, and they put this also at the service of operators. I'd like now to turn to Luc, which is here. So Luc, you're one of the problem solver of space debris. Maybe you can introduce briefly your mission and also how you intend to use this knowledge created by Thomas and Moriba, and how this is critical for your business.
Okay, good. Thank you. Thank you for having me. And a brief is not something I'm able to do, so I'll try to make it short. The first thing I wanted to share is the fact that what Moriba and Thomas are doing, that doesn't work. The, the, the clicker, there we go. So what Thomas and Moriba are doing are really bleeding edge in understanding what we have as an environment, understanding space, and is actually fundamental for what we actually try to do on our end. Clear Space is a spin-off from EPFL. We stem out of a project that actually started after launching the Swiss Cube in 2000. Can you push next? In 2000 and next again. In 2009. In 2009, EPFL launched a CubeSat. It's a 10 by 10 centimeter satellite that had an experiment of observation of the air glow, which is the upper surface of the atmosphere. And the satellite has been launched at the altitude of a collision that we see on the screen right now between the Cosmos and Iridium collision, so at 720 kilometer altitude, which actually produced two problems. The first one is that the Swiss Cube doesn't come back in 25 years, which is the guidelines. Normally, every satellite should come back into Earth atmosphere and low Earth orbit within 25 years after the mission. And the other problem that happened is that we received a lot of conjunction messages from JSPOC, which are essentially message that the US Air Force at the time would give, indicating that your satellite might collide with another space object within the next 48 hours. So we received a lot of those notifications, and that essentially triggered the problem, the question inside of EPFL, what do we do about it? In 2012, EPFL decided to launch a mission called Clean Space One, with the objective to go pick up the Swiss Cube. And in 2018, after seeing OneWeb getting financed and the changes happening in the space industry, we decided we have to do a spin-off and move faster within a startup. So one of the problems we try to address, one of the logic behind what we try to do is not to remove all the small objects, which are the major risk for satellites today, but address the source of the problem, which are larger objects which fragment. And the logic behind that, if you see on the screen, what you have on the left-hand side is the orbit of the Cosmos before the collision, and on the right-hand side you see the Cosmos Iridium debris today, right? So it's obviously much cheaper and much more effective to remove satellites when they fail before actually they fragment. Because once the fragmentation event occurred, it becomes extremely expensive to go from one debris to another to be able actually to pick them all up. Either you need a huge amount of time or you need a huge amount of propellant to be able to do that kind of operations. So what really moved us is those figures. So those are figures coming out of a study from Darren McKnight that identified the most problematic objects in orbit. And what we have today is more than 5,000 uncontrollable satellites or rocket bodies in orbit. And every single year, we've been adding 74 new ones to this list over the past 20 years. In comparison, we obviously have less operational satellites today. But what happens at the same time right now is that we start launching a huge amount of satellites into space. And to give a comparison that is easy to understand, it's a little like if we would have a motorway network operating without tow truck for 60 years, right? And today on the motorway, we don't leave the broken cars on the motorway for obvious reasons. And the difference with space is that the cars would be, even when they're broken, continue driving, right? You still have motion, you still have a speed. And the other difference is that the speed is 28,000 kilometers per hour. That's about 7 kilometers per second. So the problematic has to be addressed. And one of the measures, obviously there's several measures to create a sustainable environment, but one of the measures is go remove the objects that are up there. And that's what we're working on. So what we identified here is where are the objects that are not functional in orbit. It's another way of looking at the databases. And what you can see is that there's a few set of clusters which are really problematic. The objects in red that you see there are the 50 most problematic objects identified by Darren McKnight in orbit. So what we're looking at is those objects and thinking, okay, how do we remove the objects from space, right? How do we do a tow truck? How do we move those objects? So ClearSpace started in 2018, and by mid 2019, we won a tender with European Space Agency to lead the first demonstration mission. So the objective is to go pick up an object that belongs to European Space Agency. You can see the object on the right. It's a cone shaped object, which is a payload adapter from the Vega launcher. ESA has a couple of those in orbit. We chose this object because it's a very simple object. It's relatively sturdy. There's relatively limited chances to produce more debris in the operation. The operation itself is already very complicated because you have to do a rendezvous with an object in space. You have to safely approach it, and then you have to capture an object which is orbiting in microgravity in a frictionless environment. And we have some astronauts that have experience with capturing object in space here, and it's really a challenging exercise. So the autonomous operation behind this mission is not a simple one to do. The objective is to fly the mission in 2025. Today, we have a team of about 50 people in ClearSpace working on mostly on this mission, and an industrial team of about 20 companies collaborating with us on this mission. We kicked off the activities in June last year. So the baseline of the mission is going into a commissioning orbit where we will do first commissioning of the spacecraft, relatively low orbit. So if anything fails, it comes back into Earth's atmosphere in a relatively short time frame. And then we will do target phasing. This means we will align the orbits of our spacecraft or of our chaser with the orbit of the object we will go pick up in space. Then we go up into operational orbits where the object is, where we have far range rendezvous, then closer range rendezvous. Then we do the capture. We reconfigure the stack because we change the geometry of the complete object. We have a change of the mass, a center of mass. So we have to be able to navigate the stack. Then we do a deorbiting operation where we just slow down the object we pick up in space and re-enter it into Earth's atmosphere. So one of the elements around the space debris problem is that it's actually transcending borders and applications. This means that we all share the same space, whether we are American, Chinese, Russian, European, Brazilian. So we all operating in the same environment. And we also operate a commercial operation in the same place as military operation or institutional operations. So it's really a problem that has to be addressed and where international collaboration is fundamental. So when we approach the problem, we have a few lines in which we try to stay in. The first one is obviously we want to build a sustainable solution. We want to bring the cost of that kind of operations down, use a reusable platform. We want to obviously work with due regards to others, minimize debris generation, interference, collision risks, and operate essentially transparently to actually address the problem of sustainability. This is really what drives us, how we approach it. So I've got a short video that presents the mission. The problem of space debris is not something completely new. What really made the difference at some point was the collision between the Cosmos and the Iridium satellites in 2009.
That collision between those two objects created 2,000 debris. This was the first big collision, and it woke us up.
We are currently working on ClearSpace 1, a mission to remove a defunct object from Earth orbit, and that program will build the fundamental technical building blocks that we will then be able to apply to a wide variety of in-orbit services.
At that point, it will be a tilt. The operators will have suddenly the opportunity or the possibility to remove their satellite once they are non-functional anymore. That did not exist before.
And if we can do what we do today, is because before us, there were a generation of pioneers in the space industry that did miracle after miracle. I think it's our turn today to make the future of the space operation sustainable. And this is what wakes us up every morning. This is why we work all the working hours we do, because we believe that we can bring this change. Today's the day to actually do it. So that gives you some background about what motivates us and why we do what we do at ClearSpace. And obviously for an operation like us, having quality data, understanding what the environment is, where we're going to operate, what is the attitude of the object we have to pick up? Is it tumbling? Is it not tumbling? In which orientation is it? Is it complete? Is it incomplete? Are really critical information for us to actually do our operation. So that ties in very nicely in what Moriba and Thomas are doing, which is fundamental if we want to be able to operate on long term in the space environment.
Thank you, Luc, for this very nice presentation and also for those words. Yeah, I do remember when the Iridium Cosmos collision occurred back now almost 10 years ago. I was a student back then and had also to propagate those objects. So that was always, yeah, waking up call. And that's also what brought me also into the space sustainability topic. Also, you mentioned also that, yeah, what you want to do is also to have a sustainable solution. And so we are also actually talking a lot about what is space sustainability. So I like to ask to the panelists, what is your definition of space sustainability? I think there's also a lot of discussion around these thematics. And what are the metrics that are available around space sustainability? So Thomas, if you want to start.
Yeah, thanks, Emmanuel, for this very interesting question. And it's not, there's no simple answer. I usually have a very simple one, which means that to me, sustainable use of outer space would mean that my children and my grandchildren can still operate assets in near Earth space in a safe manner, and that they could even go up there and work like Claude and other of the astronauts present in the audience have been doing, and being still safe. But I mean, this is a very general definition I have. The question is, of course, what are we going to accept as a risk? First of all, I think sustainability would mean that we stabilize the risk, that the risk, you know, is kept at a certain level, the risk induced by space debris or by space operations in general. And secondly, our societies will have to come up with with an idea about the level of risks we are willing to accept. You know, are we willing to accept that the risk is so many percent that my satellite is going to be taken out of service by you know, a space debris environment within 10 years, 5 years, whatever. And the same about the risk for human spaceflight. So this is something we have not yet been addressing. I mean, we are trying to come up with indices or any other means of quantifying, you know, what is good, what is bad for long-term sustainability. But I don't think we have been addressing the question, what are we willing to accept in terms of what is sustainable and what is not. It's the same with the climate discussion. You know, are you going to accept 0.1 degrees Celsius, or are we going to accept 5 degrees Celsius increase of the global temperature within 1 century, for example? First of all, we need to know what it means, and secondly, we need to know what we are willing to accept as humanity.
Thank you, Thomas, for this answer. Moriba, I know you're also working on, well, actually, we are working together in developing and implementing a matrix around space sustainability. Maybe you can tell us also a few words about the space sustainability rating.
Yeah, I mean, look, in terms of in terms of sustainability, part of it is the ability for us to explore space. The ability for us to continue to have unhindered access for a variety of peaceful purposes. One of the things that I see that is very challenging that's happening is, and again, none of this has to be nefarious or malicious or anything like that. The traffic is increasing in ways that we can't necessarily predict. And so even for science, even for climate change, if you want to monitor a specific part of the earth at a given time, you may not be able to get to that part at that time because there's a conflict in terms of a collision risk, right? So people have to alter their trajectories, which can impact science and impact many other things. So sustainability in that respect, because we have a current situation that does not scale well. We all know that. But then, also sustainability from an environmental perspective, looking at near Earth space as an additional ecosystem to land, air, and ocean. We want to say and land, air, ocean, and near Earth space. Even though we don't have a bunch of biological systems in this near Earth space ecosystem, save astronauts on space station and people going on joyrides and these sorts of things, right? But still, I think we need to loosen up our definition of ecosystem so that we can incorporate, near Earth space, because near Earth space is in need of environmental protection, just like other domains. And so the sustainability for me is both the human activity and being able to sustain that, and how we need to explore and participate in this domain, and the environmental sustainability perspective. And so the space sustainability rating really goes to trying to address these things in a way that does not penalize, but more incentivize people to do things and behave in certain ways that can measurably deliver on improving that sustainability from both space activity perspective and an environmental impact perspective.
Thank you, Moriba. And that's also make me think that when you're talking about incorporate near Earth space into the environment, there is also a group of people also advocating into adding a 18th SDG, so Sustainable Development Goal, in order to protect also outer space. So this is also very important to take that out with you. Now I want to turn also to Luc. Last question before I give then the floor to the audience, so you can start thinking about the questions that you have. So you mentioned you want to develop a sustainable mission. So what does it mean concretely for you? What are the steps that you're taking in order to be sustainable?
So there's obviously several steps we take to make sure that our missions are sustainable. Well, the first one is make sure you don't produce more debris. And I think that's the first rule that we have in the requirements that we received also from ESA. Don't produce more debris and respect all the standards when it comes to make sure that this doesn't happen. And this means that you have to be very careful in the design of your mission, the design of your robotics, design of your navigation, everything you do. You just make sure that you don't produce more debris. And for us, it's especially important because we go in contact with another object in space. The other dimension is the design for demise. This means the platform is designed to re-enter Earth's atmosphere. And obviously on the long term, when we look at our operation, the objective is to have a traceless operation, which means that we don't leave anything in space at the end of the exercise. And that's absolutely at the center of what we design. And I think to also add to the question of sustainability, and I think it's hard to complete more than what Thomas and Moriba said. I think it's really a question of mindset, how we look at what we do, how we look at progress. Most of the progress humans do is mostly focused on the first benefit of it, but don't really include closing the loop and making sure that we reestablish a balance in our environment. And this means a fundamental change in terms of way we approach the operations we do. What we think also is that when we cost a mission, we have to cost a complete mission, not just all the way to the operation and maybe to the orbiting at the end of the mission, but really taking into account that you might have to actually actively deorbit the subject afterwards. And that's one of the things we say regularly when we talk also with the agency. We say a mission like, for example, MVSat, that has a 2.3 billion overall budget, should include in its budget, in its cost, the fact that it might have to be deorbited actively at the end of its life. So if that kind of thinking doesn't get into our mainstream, it's going to be really difficult to produce the change we need to introduce. The other dimension regarding the understanding on Earth that sustainability in orbit is important is that most people don't understand that the space operation, the space infrastructure, is a foundational block of our modern way of life. We can't live without it. It's not possible. It's not an option, right? Stopping our space infrastructure is drawing us back 50 years. And the more we move forward, the more it's going to be the case. So we cannot implement an infrastructure which is not sustainable. It's not an option we actually have. And in that sense, when it comes to sustainability, we are convinced that actually failure is not an option. We cannot afford a failure when it comes to making sure that this operation remains sustainable for decades, for the next generation to come.
Thank you. We could even say sustainability is not an option in this case.
Exactly.
So yeah, coming to that, yeah, I really understand this mindset change, and I think we are all also facing this in our everyday life. The expo also here is also really focusing on sustainability, but also on Earth and in space. Now I'd like to turn the questions to the public. So if you have a questions, Vincent here is gonna take the mic. Please ask the question in the mic, and then we'll be happy to answer them.
Nice to meet you. Thank you very much for the talk. It was really impressive. My name is Clésio. I'm director of the National Institute for Space Research in Brazil. So I saw that Thomas is looking for some place in Latin America or South America to put a laser. I'll let my card here. I'll be glad to facilitate to have another institution, not INPE, but the National Laboratory for Astrophysics. We have a Pico dos Dias. We have, it's another of institution of Minister of Science and Technology, one of the 27 we have there. And I'll be glad to facilitate the communication with the director of that institution. So I'll let my card here. So going to the questions, I would like to know, Thomas, what kind of laser are you looking for? Not sodium nor potassium for sure, because we have the layers that measure in the 85 kilometers, 200 kilometers. So maybe this can introduce some errors in your measurements. Another one for Moriba, sorry for that, but I'm very interested in this talk. Now talking for INPE, we operate 5 satellites right now, and we have a center for operating and downloading data in satellites. So I'm very interested in your catalogs. We have to do maneuvers every single day to avoid collisions with Amazon 1, for instance. We operate for monitoring the force. Every single day we have to do maneuvers. I'll be glad to have access to your library. I mean, is your library open to the community? It will be commercialized? And sorry, look, but again, very interesting talk. Why are you using panels, solar panels in your satellite? How long does it take the satellite to take that orbit, deorbiting the debris? You are putting for a long time? You are expecting long life? That's why you're putting panels in your satellite?
So we can start.
Sorry for too many questions.
So there was 3 questions in one. From Thomas, so you had this question about laser ranging. If you want to start answering it.
Yes. First of all, thank you for your offer to collaborate. I will of course contact you. That's one of the objectives, I would say, of this event here, that we get more connected and have more opportunities. So about your questions concerning the laser. So laser ranging to objects which, let's say debris objects or objects which do not carry retroreflectors, is very challenging for 2 reasons. First of all, we need specialized lasers, which are on one hand producing very short pulses so that our measurements are accurate. On the other hand, um, they should have enough photons that something is coming back. And on the receiver side, we need not really large telescopes, but telescopes of the order of 1 meters in aperture to collect these photons. And the third thing, and I think this is still key there, to have the algorithms and the technologies to distinguish the very few photons which come back in the sea of background noise, which comes from the sky or during daytime from our own sun. So in principle, we know how to do it in principle, but as I said, there is a lot of technical challenges still to overcome. But if you are interested in more details, we are very open to collaborate.
Great. Thank you, Thomas. So the second question was for you, Moriba. Is your database available? Would it be also helpful for in order to do collision avoidance maneuver for someone who is operating five satellite? Is it a possible application with your database?
Yeah, so as much as I can understand and hear people, I just put a link in the chat. If people just Google IBM Arcade, you'll find it. And yeah, for months now, we've had about 19,000 state vectors, ephemerides, position and velocity states for about 19,000 objects in 1 minute intervals available through Arcade via API. So you can just have machines autonomously tap into this, and we update. We're updating these state vectors, once a day, kind of thing. So yeah, for now, I mean, this thing is free. That I don't see any reason to change that. It's meant to be helpful to the community. So yeah, make use of it right now and participate. Help continue to develop it and that sort of stuff. So, but yeah, it's freely accessible.
Thank you. So data available once a day, so you can check then if it meets your need. And then last question then to Luke. Yeah, solar panels. Why? How long it takes to go to the orbit?
So the mission is the first mission is going to fly a few months. It depends. Right now we don't have the exact duration because we have to do some orbital phasing, right? This means we're going to be injected in the right inclination, but not in the right local mean time. And then depending on where you are, you might actually have to phase during 6 months or 9 months to be able to get aligned with the target. And if we're lucky, we can be injected fairly close, but that's not necessarily the case. The other reason why solar panels, because we have multiple processing units on board. Obviously, there's an onboard computer, but we also have sensor data processing units, which does sensor fusion. We run some machine learning on board as well. So there's a consumption that is a little superior to what you would have on a spacecraft where you would not need that kind of capabilities. We run more sensor that actually needed on this mission, so we do some overkill there, mostly because we want to compare the different strategies of how to do the relative navigation and the autonomous activities in proximity. So we have more sensor flying than are actually needed, and probably in the commercial mission, the idea would be to repeat operation. So in that case, you'd like to remain a few years, but then at the same time, we will reduce the consumption profile on the platform on the long term. I hope that answered the question.
Thank you. So I think there was a question there. Yeah, the gentleman.
Yeah, hello everybody. My name is Paul Razmaev. I'm from Latvia, representing company Evantech, and we are developing time of flight systems, time taggers, timers, and we are working with satellite laser stations around the world. So like more than half are equipped with our timers. And you mentioned that you're like building both ground stations and you're like timers are you using to precisely track the debris location. And for satellites, if you have a LiDAR system or altimetry system, probably you are outsourcing it from somewhere else. What kind of system it is and what kind of LiDAR it's probably you're going to use.
Okay, so I get this was a question for Thomas or maybe Moriba about what are the time-taking system that you use on ground stations that track satellites.
Okay, I may perhaps give an answer to what we are using for the laser systems and for the optical systems. So for the laser ranging systems, we need, of course, very, very precise time tagging. So the absolute timing doesn't need to be so precise. Here we have, let's say, GPS disciplined quartz clocks, which give you an accuracy of the order of 10 nanoseconds. That's fine for the absolute time tagging, but the event timer needs to be much more precise. So the time of flight needs to be measured with an accuracy of the order of less than 10 picoseconds. So this is the really demanding device. And in order to make sure that the underlying time base is good enough, we use hydrogen masers. So we have a hydrogen maser in the basement of our observatory. For the optical observations, the time tagging is more relaxed. So we need, let's say, if we are observing low Earth orbiting objects, we need accuracies of the order of tens of microseconds, which is not, let's say, a challenge for timing systems, but it's a challenge to relate that timing to your detector, depending on the type of detector. If it's a classical CMOS or CCD detector, CCD is very challenging to have that accuracy in time tag with the images. CMOS is a bit less of a problem, but I think the main issue there is how do you relate your precise time tag from your timing system with what's happening in the detectors. So this is still not solved for all type of detectors, but the modern type CMOS, I think there we are in a good way.
Sure. We have as I mentioned, both terrestrial and space. For terrestrial timing systems, our precision is less than 2 picoseconds. So basically, we are precise enough to solve your problem. And to synchronize all the systems among each other, we can also help to also work with Ericsson takes. So basically, we can help with this as well. So basically, I think we can help solve your problem. If it's still not solved? I can leave my card and we can contact afterwards.
Yeah,
Thank you very much.
Thank you so much for this offer. Other question from the audience? I hear.
Thank you very much for your presentations. My name is Chloe Carrière. I'm an EPFL student and here working at the Swiss Pavilion. I was wondering, because since the rise, let's say, of space tourism, now in the public opinion, space is becoming an unsustainable field. And we've been talking about sustainability in space. And I was wondering if in the rating that you're creating, you're also taking into account the ecological impact in terms of production of space missions and not only debris.
Okay, so do you want to take this question, Moriba? What is the impact in space tourism and how it's taken into account in the rating?
Look, certainly what you bring up is a very good point. I can tell you that the space sustainability rating, given that it is, it's a composite index of sorts, right? So it's taking into account things from many different, sources and, effects and impacts. We're still on the front end of this, meaning we have ideas. We have not implemented all these things, so we don't know what the result is yet. I think we're still exploring and getting these sorts of inputs and finding ways to incorporate these things. So I think we're in this crawl, walk, run where now, EPFL is leading this next phase we have a few people. Use cases are really what drive things, right? So basically it's like, okay, if we just sit down and try to intuit all the things that might have interdependencies, we just will never get there. And so we like to do a pay as you go development, meaning use cases tend to drive the things that we incorporate. And so for sure, given that you're in the same room with Emmanuel, right, I think it makes sense for EPFL to take this in as an input. But yes, in principle, the SSR should be able to accommodate quantifying the effects and impacts of space tourism, these activities, and even things done on the ground which have a consequence to long-term sustainability of the environment.
Yeah, thanks, Moriba, for this question. Indeed, we can talk about this after. I would also to let you know that you have flyers on your seat. So with some preliminary information, then there is a QR code to our website where you can also have more information. I see there's a question here in the front.
Thank you, Vincent. I'll just make the most of organizing the event to ask questions too. I hope you don't mind. We have the chance of having our Brazilian friends here who are leading nation in terms of environmental international governance. And Chloe, thank you very much for your question. I think this brings us to another point whereby how do we manage these common resources? We're seeing efforts which are being made for the seas. We're seeing a treaty in the Antarctic, which dates back from the 60s actually, but prohibits the use of stocking nuclear waste, for example. Correct me if I'm wrong, but the last major treaty for space dates back from the 60s, something like that. So the 70s, exactly. And I think this needs to be updated. And I was wondering what can we do, number one, to solve this problem? And number two, to bridge the gap between governance and the public sector and the private sector. I'm not sure if any of our friends from Brazil would like to maybe share a few words about the Brazilian perspective on this. I think that would be very interesting for us to hear. Or and if any of the panelists would like to comment this, that would be great. Thank you.
Yes. So.
Emmanuel, are you waiting for a response?
We're waiting from our Brazilian colleagues for a response, but maybe if you
okay,
want,
I see.
If there's someone who wants to answer, yeah.
We don't have the president of the Brazilian Space Agency here, who would be the best person to answer these questions, because they are working exactly on some of these subjects there. And so I don't have the entire answer for this. Yes, I don't have the entire answer for this. But what I can say is that we have some work done and being done actually at the Brazilian Space Agency, looking at those issues. I don't know if anybody has anything else, but it's a pity that he's not here. He's in another event here.
So we'll definitely follow up with you to get in touch with him to have the Brazilian perspective. I don't know if Moriba, maybe you wanted to answer also the question on your perspective on what can be done and what are the next steps in terms of governance.
Yeah, so here's the thing, right? Yes, the treaties have been in place for a very long time. Are we gonna come up with new treaties anytime soon? No, that's just not gonna happen. What can be done realistically? Look, based on the current treaties, again, we still don't even have quantifiable evidence of how people are interpreting and implementing these things. Let's start there without trying to point fingers or assign culpability. Let's just say, here are all these sources of information regarding how people are currently interpreting and applying this stuff, and let's see what that looks like. And then we can say, is this meeting the intent? Is it meeting the intent of what we need? And if the answer is no, then let's have a conversation around that that's evidence-based. So that's, I think, something that can happen. Given that, I think, and very interestingly, right, states that are parties to the treaties are the ones that have the responsibility and the burden for liability and all these things, not individuals, not companies, but states. I think states just need to agree to say, look, we are the ones who are authorizing activities and all these other things. Let's work holistically to prevent the detriment of this environment, because it's in all our interest that we are still able to participate in this endeavor of space exploration and in situ resource utilization and that sort of stuff. I'm even going to say this, which might be a bit controversial, but you know, that's me. I firmly believe that certain indigenous populations have a lot to teach us about how to live sustainably. There's something called traditional ecological knowledge. It's a thing. The Inuit from right in the Arctic, the Maori in New Zealand, the Aborigines, these in pockets of indigenous people have been custodians and stewards of their environment for eons. I'm talking thousands upon thousands of years, right? They've developed a tradecraft to know how to be sustainable in their own environment because their livelihoods in part depended on it. So I think this idea of thinking about things in terms of interconnectedness, I think this idea of traditional ecological knowledge, what are those principles and tenets, and to what extent can we apply these for space? Let's bring these indigenous people to the table and say, hey, what have you learned over, you know, the last 10,000 years in terms of ways in which you do things that are sustainable? I'm just going to say really quickly here to add on to this as an example. You know, Mother Nature, when left to her own devices, tends to seek equilibrium. Okay, that's the evidence that I have so far. And I can tell you that when we launch things every couple of weeks, dozens and dozens of satellites, we don't give Mother Nature the ability to provide us feedback on the unintended consequences of our behavior. This idea of before you start doing a lot of things in the environment, observe, understand the relationship in, you know, that things have amongst each other, and try to allow the environment to provide you feedback so that your behavior, intentional, unintentional, is you know, long term. I believe these people have something to say. So that would be my thing. Governments are the ones that are responsible. They have to agree on some things. We're not going to get a treaty anytime soon. And we should be looking to the voices of indigenous people and how their ideas of stewardship and custodianship and how they have successfully been able to achieve environmental sustainability. Can we learn from that to apply that to space? Thank you.
Thank you so much, Moriba. And I really also like your ideas also to look at the traditional ecological knowledge. I think this rings a bell to a lot of people here in the room. Just also to follow up on your question, Dante, also I would like to turn to Luc, who's selling a service. And so I was wondering also in terms of governance, who are the people that are taking responsibility for the debris and that are going to pay for the services? Are you saying it's more commercial actors? States are also coming to you to remove their own debris? What is your perception on that?
Well, what we see is that there starts to be more understanding and actually action taken by agencies right now, because we have this, well, obviously the ESA mission that is going on, where ESA decided actually to take the risk also not only to do a mission to remove an object where nobody actually forced them to do it, but also to actually choose a startup to do so. But then the UKSA, the UK Space Agency, is now starting another mission to remove 2 objects. So there start to be a sensitivity to the problem, and there starts to be some action, and that's a very good sign. But it's interesting, when I met Muriel at the beginning, she showed me the evolution of space debris, and it struck me. I thought it's amazing, and the space industry is accelerating really fast in a pain point that accelerates exponentially. So I just asked her, what do you want to do? You want to remove the Swiss cube, or do you want to remove everything? She said, I want to remove everything, right? And so we thought we have to find a sustainable way to do that financially. We have to find a model that actually can finance itself to do so. And so we discussed with investors, with a lot of people, and everybody would tell us the same thing. They would say, nobody's ever going to pay for that. Where's the policies? Where are the policies to do that? And we would face a lot of excuses in the exercise, and everybody finds excuses. Those are not my objects anymore. You ask some people, say, oh, that was the previous company that did them, belongs to them. Or a state says, okay, that was the previous government before me that did it. So we would see a lot of excuses in the exercise. And another thing we realize is that actually the people that are empowered to take decisions are not necessarily aware of the problem. And we saw that we had this discussion around the Swiss cube, because at some point we received a conjunction notification that a Fengyun 1 piece of debris passed by at less than 100 meters from the Swiss cube. Well, obviously it's an opinion. Again, we're not sure how close it was, but we saw that and we thought, and I had the discussion with Muriel. I said, well, what happens when that happens? Say, well, we actually, all the engineers, they sweat, right? They think, hopefully nothing happens. Well, in the case of the Swiss cube, we just pray, because that's all we can do. We can't do anything else. And then there's all this process of making a cam maneuver to avoid the object, yes or no, the decision. I mean, there's a lot of work done and a lot of stress around that. And then on the next day, it's passed and it's okay. And so everybody gets back to work normal and say, well, but this is a problem, never gets onto the desk of people that have the power to take a decision when it comes to budget. So we thought, let's publish it. Let's publish this. Let's put it into the press. Let's publish it outside. And I think that's one of the fantastic dimension of what Moriba is doing, publishing the information, making it visible. Because when we trash something in our backyard and we never see it again, we tend to forget about that kind of things. And the problems we don't see are really hard to solve. Nobody really cares about them because nobody sees them. The other thing that we realize is that the policies, and especially the space liability treaty, says that above 100 kilometers, once an object is in orbit, the liability is with the launching states in plural. So there's many people that might be responsible, but that fault has to be demonstrated. So let's imagine I do a constellation of satellites. I'm big a constellation in the United States. I have many satellites operating, and one of, for example, a UK constellation has a bunch of satellites that fail, and one collides and generates a field of debris, disabilitates a few of my satellites. What can I do, right? Then it's between states. So this means the state should go to the UK and say, well, you have to pay for that, right? In the UK space law, it says that the operator is responsible. So at the end, it goes back to the operator. And what will the operator do? He will show up with a pile that high of all the proofs why he didn't commit the fault. He will say, I bought a fantastic satellite from Airbus. Airbus is a very reliable company. Everything is duplicated. We measured the tension every single screw. We made sure that we made all the tests necessary, and we launched with a very responsible launch company. And then at the end, we had the best team in the world to operate it. Everything is traced, right? When this satellite failed, I had the best team of engineers to try to repair it, to recover it. They worked 6 months on it, could not do it. Nobody could have done it better. It's an act of God, right? Where did I commit a fault? And it would be really difficult to demonstrate the fault in this exercise. And that's one of the problems we have with the current policies. How do you demonstrate fault? It's almost impossible. Now, on the street, you cannot do that, right? On the street, you buy a very reliable car, you buy a Mercedes or a Rolls Royce, and you drive it's an expensive car, right? And it fails on the overtaking lane, and it fails there. And you're a automotive engineer, so you know how to fix those things. You spend 2 hours trying to fix it, you find out you can't fix it, so you go buy another one and continue driving. You commit to the fault, right? Because you could have actually called a tow truck. You could have paid for it. So the question will be, how can we change the dynamics of operation, the choices that are made within agencies, the choices that are made within a commercial operator? How do we change this behavior? And that's really one of the questions we had from the beginning. And I think the first thing is transparency. We have to make the problem obvious and clear and visible, and that the rating makes a lot of sense for that. The publication of the data makes a lot of sense for that. And making sure that this gets into the press and becomes a subject is really important, because otherwise nobody's going to ever give priority to the problem until it's really too late. And there's some orbits where we already start seeing Kessler syndromes. At least that's the feedback we get from CNES, for example. The identified orbits where there's more and more objects, and we don't launch specifically more satellites in those orbits. So it is really critical that today we get to this understanding, and then there's very many models that can work to actually finance that kind of operations, right? There's different ways to do that. You can do like the carbon offset, you do an offset model, right? That's one possibility. You can do an insurance. You can do like the AAA in the United States or the TCS in Switzerland or ADAC in Germany, where it's an insurance plus service. You can do, there's a lot of models that work. And when you really make the equation, you can bring, it's possible to bring those operations into an environment where it is viable, feasible, and affordable. This is possible. I hope I answered the question.
Yeah,
It was a
thank
little
you.
long.
That was a great answer, and I think it's perfect also to conclude this session. So that was a really great and intense conversation. We could learn a lot about like how we create this, how we create this knowledge, this information that we need to better understand the space debris population from this observation that is performed by astronomers into putting it in a database in order to create digital common of information or a huge library that can be used by scientists, but also by policy makers to do evidence to take informed decision, but also by operators. We also look also of what is space sustainability and how it's important also to talk about it, to communicate and to publish this information that we have and to have more transparent information and to make it accessible also to the public and also to the right people that can take decisions. And finally, we also talked a lot about how we need to change our mindset, to change the dynamic of how we operate in space. But while also looking forward in the future, we also had a great reminder also from Moriba that we need also to sometimes take a step back and also observe some of the people on Earth that have been that have a traditional ecological knowledge and think about that. So on that, I wanted to thank everyone, to thank Thomas and Moriba that connected also from far away today, from the viewers also online, and for everyone who made it in person today. And I think Dante has the last word also to say to everyone.
Ladies and gentlemen, I just wanted to say thank you very much to our speakers, to Emmanuel for your moderation, to our guests. We are Swiss. Might not be as social as Brazilian people. However, we do have a tradition which we call apéro. An apéro is something where we gather between friends after a long day work and we have a glass of nice, fresh Swiss white wine. And right now, we would like to invite you to have a small reception next door. We're having soft drinks, of course, waiting for you, but for the ones you want, we have also nice, fresh Swiss white wine. So on these words, thank you very much for attending our event. It has been a pleasure on behalf of the Swiss Pavilion to have hosted you. Thank you very much.
So welcome everyone. Oh, I have to wait. Welcome everyone, all distinguished guests that are here today and also our viewers online. Welcome and thank you for attending this event. My name is Emmanuel David. I'm Executive Manager at EPFL Space Center, so the Swiss Institute of Technology in Lausanne. And today we're going to talk about sustainable space logistics, which is a research project that we are running at EPFL. Before starting, so I would like to introduce Dr. Somanath, that's going to give a few introduction remarks. He's the director of the Vikram Sarabhai Space Center at ISRO, the Indian Space Research Organization. So if you want to come.
Thank you for the opportunity to meet you, to talk to you. I also want to tell you that I have another hat. I'm the director of the Indian Institute of Space Science and Technology. It's a part-time job for me now, which is a university deemed to be university under Indian Space Research Organization, creating capacity in engineering and science to feed to our space program. Which just started 11 years back and doing well, and one of the important source of people for our space program. Having aerospace, avionics, as well as physical sciences in like chemistry, biology, and mathematics, graduation as well as research. We try to do it with most of the Indian space research organizations, looking at the problems there and trying to do research also in humanities, looking at how the impact of space science and technology created benefits to the society also is one of the topic that we do address. Coming back to this, yeah.
He's also member in Space Commission, is the apex body in India for dealing with space activities, and he's also vice president of IA.
Okay. Okay. Thank you. Thank you, Sudhir. So I know I'm here not to speak about myself, but more of what we can do together. I think that's very important. I'm really happy that we are having this program connecting to space. I really understand that you are trying to create that similar type of ecosystem within Swiss nation, and also to contribute to the European space program in general. As far as ISRO is concerned, we have a long history of cooperation with all the spacefaring nations. Started learning space technology from others. I'm started with the early part of our program, brought the propulsion systems platforms, at least in the optical domain, to look at and catalog and also add to the global data on space debris, and also making use of some of the global data to make better predictions and models for safe space exploration. So these are some of the things that we do. We hope that with you and with the Swiss federal agencies as well as the university that you are, I believe that we will have a greater way to interact and then know, especially at the scientist level and students level. Thank you so much.
So thank you very much for those introduction remark, and I want also to note that so Indian-Swiss collaboration also goes back because the first Swiss satellite, Swisscube, was launched on an Indian rocket, so back in 2009. So our next distinguished speaker is Tim Florer from the European Space Agency. He's the head of the Space Debris Office, and he's going to give us a short introduction on his activities and on the space debris situation.
Yes, thank you, Emmanuel, for the nice introduction, and good morning, everyone here in Dubai, and also good morning out there in the internet. Yes, it's a huge pleasure for me to be here today and to introduce a topic that is really close to my heart and what we are doing at ESA as well, which is space logistics and the relation to space debris, which is my daily life for many years already. We all know it, and you have heard this already from ISRO in the introduction, that what we are now doing in space and how we use space is an indispensable part of our daily activities. Space is everywhere. We are using space knowingly or not knowingly every day, multiple times. A friend of mine assessed, just as a joke maybe, how many of his apps on his mobile phone are using space infrastructure or space data, and it was more than half of them, and Candy Crush was not among them. So really what I want to say is we are observing an enormous change these days. We are part of a transformation towards space as a commercial resource. And how did we get there? Well, we are launching satellites now since 1957. This is not a secret. And if we look into our records, we see that we did about 6,000 launches. And these 6,000 successful launches, or more than that, placed 12,000 satellites into orbit. Out of these 12,000 satellites, 7,500 are still in orbit. And out of those, and this is the big number to keep in mind, more than 4,700 are active. And if I think back some years ago, there was always the number of around 1,000, 1,200 active satellites just a few years ago. And now we have 4,700. And the forecast, if you look in the next years, will continue like this. We will be launching more than 1,500 satellites every year. And this is more than we had active in total just a few years ago. So you see the drastic changes that are coming. How do we know all this? Yeah, you heard just about this. There's space surveillance, and in space surveillance, we are building and maintaining catalogs of the objects in space. And from those, we also know about the problem of space debris. And space debris mainly goes back to more than 500 fragmentation events that we know of. These are collisions and explosions mainly that have happened. Some of them very severe, creating thousands of fragments. Some of them smaller, creating only few. But they have happened. And from what we placed into orbit, we have to face it that also fragmentations will happen in the future. Yeah, and that places more debris, and more debris can create more fragmentations. And that's a situation we have to deal with, and we have to manage it properly. At ESA, we are building models to help the design and operation of spacecraft in a sustainable way. And our master model predicts that from statistical surveys, we have now more than 36,000 objects larger than 10 centimeters in orbit. And if you go to 1 centimeter objects, already more than 1 million objects. And even a 1 centimeter object has enough energy that upon a collision could render your satellite unavailable. And if it's more than a few centimeters, it may lead to a fragmentation again. This all, and allow me to point you to a report that we do every year. You can read in our environment status report that ESA does. It's really available on our website, and it's a very complete compendium of statistics, graphs, and numbers that you may want to look up. So how that all, what can we do about this? And there are solutions, and we will hear about this in the talk today. One thing that is critical to understand that orbits are a natural resource of a limited capacity. And using this capacity wisely is our goal. And this all leads to the overall goal that we have to avoid a space debris crisis to happen. Another crisis on top of our crisis is not what we can afford. And I may point that there are space debris mitigation guidelines out there. There are, at the UN level, there are voluntary goals that have been established in 2019 already. And they all are very good in outlining what can be done. One thing we should not forget about it, all these what can be done relates to costs in the design of the satellites, but also in the operation of satellites. And coming now to something I do daily is I'm responsible for collision avoidance at ESA satellites. And I can tell you from the daily life, this has changed also in the last few years. We often saw close approaches with debris satellites, but now the things are getting different. We are seeing more and more close approaches that we need to take care of with active satellites. So where there is another operator, and this changes the picture. Because if this is a debris, it's clear, you have to avoid. But if it's another operator, it raises a lot of questions. What are the capabilities of the other satellite? What are the plans of the other operator? Are there changed plans? Are they maintained? And you see, this all requires, at the moment, manual coordination. And speaking to my team, they are not happy to do this coordination during the weekends because celestial mechanics essentially doesn't care about weekends and holidays. And automation is the key there. We have to get digital there. We have to automate. We have to use technology that is available outside. Machine learning in decision processes is something that we are looking into. And automating collision avoidance in the support of coordinating space traffic is a technology goal that also ESA follows in the space safety program that we have. So that's why I'm super happy that I can introduce now our speaker, Professor Jean-Paul Kneipp. He's a full professor for astrophysics at EPFL and the director of the EPFL Space Center. And he will introduce now how sustainable space logistics can help me in my problems. And also what is done in activities at the EPFL Space Center. Jean-Paul, floor is yours. Thank you.
Thanks, Tim, for the introduction. And it's a pleasure to be here and to give you my speech about sustainable space logistics. So let's see, I have a few slides, but hopefully we'll have some interaction also. Something not working, or maybe you have to do something special. Oh, it was on the on, okay. Maybe you can help me there. Okay, maybe I'll just introduce myself. I'm a professor in the astrophysics at EPFL. I've been at this university since almost 10 years now. And I've been, basically, my research in astrophysics is about mapping the universe. And when I say mapping the universe, is really understanding the distribution of galaxies in the universe and what they teach us about the universe. And when I do that, I'm collecting a lot of data, data from the sky, from the galaxies, I'm doing that with imaging data, but I'm also doing that in spectroscopy. Okay, no, it works. And so I'm constantly basically looking at the sky. And when you look at the sky, the first things you do when you take an image, you will remove all defects that that are in your data. And more common defects these days is satellite tracks. And so I decided to develop maybe a line of research, and I will talk about it a bit later, about monitoring these satellite tracks based on astrophysical data. A couple years ago, in 2007, so 5 years ago, I became the director of the EPFL Space Center. And at that time, there was a lot of development being done at EPFL about, what is sustainability in space and how we can make things better. And so I arrived there, and I started new research on this topic. And a main research topic we've started only 2 years ago is what we call sustainable space logistics, and trying to understand, we can make space more sustainable. And that means, you have to think differently. But let me just introduce a few numbers from an astrophysicist perspective. Okay, people like to think of, possible travel, interstellar travel to find a new home to live, etc. What I want to say here is there's no planet B. The Earth is our spaceship, and it will be forever. And this, despite a large number of galaxies, about 200 billions in the universe, and in each galaxy there's about 100 billions of stars, and around each star there are typically 7 to 10 exoplanets. So it's not like, our home is unique. Certainly it's not. But the distance between the different systems are really huge. I mean, the universe is really huge. If you take just the nearest star, which is 4.3 light years away, if you turn that into kilometer, it's 40,000 billions of kilometers, right? So maybe that doesn't tell you very much. So then I looked at, maybe you heard of the New Horizon space probe, who came to Pluto, which is like the border of our solar system. It took 10 years to go there. If you go at the same speed up to the nearest star, it will take you about 50,000 years. So, 50,000 years is more than, the Homo sapiens in on Earth. So it's just something, you can just, think of something like that. And I wanted to point also this picture regarding sustainability and trying to put the context of sustainability into space. Our planet Earth is a spaceship, and it's a spaceship, so it has a limited size. We can measure very well the diameter of the Earth. We can measure the landscape, etc. So the fact that the resources on Earth are limited is just that the Earth is limited, right? It's not infinite. And also, all the issue about sustainability we face today is about these limited resources. Okay, and that is a nice plot of the Earth overshoot day. The time in the year you basically spoil all the production on Earth. That's been, in 1970, it was but at the end of the year. Today is more like in August or something like that. So we could, explain sustainability by this lack of resources. And so then I bring this question to you. Are current space activities sustainable? And if we just follow what teams say, maybe there's a problem. And I'd like to link this problem to the orbital resources that are not infinite, right? This is kind of a picture of the Earth. Sorry, oops, go too fast. with all the satellites that are tracked today around the Earth. So there's active satellite, but most of them are debris here in these pictures. And you see them, different location. You see them at very low Earth orbit, so very close to the Earth, only like 600, 700 kilometers from the surface. And then you have all the more distant satellite up to like 36,000 of kilometers in the geo orbit. So I think we have a problem, and I like this sentence, Houston, we have a problem. And this is also linked to the fact that space has been turned into, a commercial aspect, which I think it's great for humanity, but it also comes with some cost, right? And I think this is the big problem is also especially at low Earth orbit because you have a density of satellites which is much larger. The problem is at every orbits, but specifically at low Earth orbit. And this is also an issue because there's more and more of these large constellation building up. So low Earth orbit is really a nice place because you're very close to the Earth. You have a very small latency of communication. You have a better resolution of your images if you look at the Earth for like observation. But of course, those orbits are rare, or at least they're not unlimited. And so we have to think about, what we should be doing to make this possible and keep using these orbits. But so we have to try to think differently. And I want to say also here that the space debris problem is, cannot be denied. I mean, I think it's a common understanding. And it's also something that could be a big issue. This is the video that was taken at the Crew Dragon separation of the last stage of the rocket, and you see that during the separation you have this debris passing by, and this was not planned. Right? This is something that had just happened. Nobody could have planned it. The debris is very small. It's not going very fast because it's more or less going in the same direction as the orbit of the rocket. But if he were going on the opposite direction at 7,000 kilometers a second, you would not be able even to detect it in this video because the time frame of the video is like only 20 or 25 per second, right? So this could be also problematic in the future for human space flights, and so we should really be aware of that. So why EPFL is motivated in doing this research? Well, I guess it comes with taking responsibility of what we've been doing. And what we done in 2009 was launching a Swiss cube. And you see the student in the middle picture that made this CubeSat. And we realized after launching it that we put the satellites at 7,700 kilometer altitude. At that altitude, a satellite will stay forever on your time life, basically. And so it will never go down. Okay. And although the Swiss cube is still active today, we can still communicate with it. Right, we cannot change its orbit. There was no propulsion on the CubeSat. And so we had a project starting in 2010, 2012, to think of an idea of a system that would go and grab the Swiss cube. Okay, this project is still not going on anymore because we have another bigger project, which is cleaning one of the ESA space debris. And that's probably better to start with bigger debris than small debris because they're more problematic. They have a larger cross section, so they could have a bigger impact if they collide with some other things. But when we did this research, we were developing all the softwares, all the ideas, the capturing system that could make this possible. And following these lines of research, we started 2 years ago a research project which we call Sustainable Space Logistics. When you think of space, you have a lot of activities. You launch things from the ground to space. You could think of capturing things. You could think of in-orbit servicing, like refueling your satellite, making life longer. So there's many activities you could think in terms of logistics in space. But we wanted to push the sustainability part because we really think that's something we need to think about in the future. And you see one of the project, the Atrios project from Clear Space to remove the ESA space debris here as a picture. Or you could think of also the reusable launcher with the SpaceX booster here. So we have to think in the future in a more sustainable way. And so we try to develop this research activity at EPFL. I want to show you a few slides about the current status, as Tim was saying, and I think the number is keep increasing. He quoted 36,000 space debris larger than 10 centimeter, 1 million above 1 centimeter. And you see when this curve started with Sputnik in 1957, it just kept growing. And you see the different system you have, and in particular you have the rocket body, which is usually the last stage of your rocket that stay in space. Now people are really trying to put that last rocket stage back to Earth, but at the beginning we didn't really care. So there's a lot of rocket body flying up there, and those are really big in general. So you really, if you have to start cleaning up, maybe you would start cleaning up the rocket body if it's possible, because they're huge and they're massive, and they have a large cross section, and that they could be giving a lot of damage. Here is what could be the situation in a couple of years if you believe what's in the press about the many constellations that are planned to be launched in the future. If you believe this picture, there will be many more satellites in a couple of years that we have today. So the situation of space traffic and space debris will be getting worse with time. So maybe this will not happen, but if ever it happens, that will be problematic. So what are the challenges? And I list a few of the research that we're working on. You could always ask yourself, is there a problem? Right. It's difficult to look at satellite from the ground with your eyes, and I realize that there's a problem. So what I think is important is to keep monitoring the situation, but keep monitoring the situation in an open way so that everyone can access your data, and that there's a common agreement that the important information in that data is shared with everyone. So I think lots of people are doing these observations, but sometimes not so openly, and that limit interaction and limit understanding of the problem. So I think looking at it in an open way is really something we should be, as human, consider very seriously. So well, the problem is known. Okay, if you're a space addict, of course you have heard of it. But if you have just a user of space through your smartphone, well, you don't really know what's going on. Okay, just because the communication doesn't go everywhere, or at least not so easily. So I think it's important, and as a university, we want to educate young people about it. And it's also important because there's more and more new faring countries to also educate those countries, because of course they see like space, like, the next frontiers, but it also comes with, things and constraint, and they should understand those constraints. So I think it's important that you share the communication around you also. So also we need to change the way we design satellite or design a space mission, in the sense that, as I was saying, you don't want to put more rocket bodies in orbit. That you, and when you think of satellite constellation, you maybe try to think of, or let's try to minimize the number of satellite in my constellation, and not just, put as many as I want because, it's great. So you have to think differently, and so, that's a bit of thinking, design thinking, that you need to do. What also is important, I think, is rating or capabilities of our satellites. And here, what we, and I will discuss that a bit more in detail after, we had this space sustainability rating that was started by a number of universities and with support of ESA to, rate a satellite or a mission or a launcher or a launching company, to make sure that they understand the problem. And we will grade them, give them a rate, whether, they're excellent, they understand the problem. That would be a great one. And if not, then maybe there's going to be more interaction with them, trying to, educate them, basically. And it's also for us a very good way to monitor how good we are doing in terms of, launching rockets, launching satellite in a good way. And of course, which is also a very visible project, is that today nobody can, go and do the cleaning because there's no garbage truck in space, right? That doesn't exist. Okay, so we have to prove it that it's possible. And when you've proved it's possible, then of course you can go and talk to people and say, okay, you have lots of debris up there. Maybe, it's time to clean up, and here's a service. So developing a service to clean space is something very important. And we have this Clear Space startup from Switzerland that is aiming to clean one debris. Of course, cleaning one debris will not make a difference, but showing you can go and clean debris, it's the first step to have kind of maybe a market after, but certainly services to other countries. And of course, this is all about, technology and thinking, but you also need to put that in kind of space law, maybe at a nation level, because it's there where, decisions are made. So we try also to develop, communication at nation levels and with different actors, so that they are aware of the problem. So this is a bit more of my daily data set I'm looking at when I look at distant galaxy in the universe. So these are two different frames separated by 10 seconds in time. And what you see in yellow are satellite tracks that are crossing my data. So my data is not really about observing satellites, it's about observing galaxies. And what you see, the field of view here is 1 degree by 1 degree. So it's typically 4 times the size of the moon on the sky. So I'm having these very big images on the sky. And I have, those satellite tracks passing through. And you see the typical exposure time here is like only a few minutes. So that means like every minute in front of my telescope, there will be one satellite passing through. And well, if you were getting very close to the data, you could see the rocket body of Ariane 2 there. And you would see it fluctuating in fluxes. So that means that rocket body is probably rotating very fast. And we estimated that the rotation was about 1 turn per second. So this particle debris would probably be very difficult to remove just because of its rotation. If you want to grab a satellite that rotates very fast, then it's very complex. But you have other satellites that don't, rotate so much. So those can be removed. Yep. You mean this one?
No. Could you please repeat for the audience? No. In this image.
In this image.
That image, sorry.
Yeah.
Top left, first block.
Yeah. This one.
Down. Is that also a satellite?
Yes, that's a satellite track.
That's another one.
That's another one. The one could be identified in the database, open database, are indicated in blue or yellow, because we know they should be there. But of course, we're detecting debris or satellite that maybe are not catalogued. Because some of the public catalog, you don't get everything that exists. You only get part of the data. Like if you look at the US catalog, there's a number of military satellites that are now listed. So that's the thing about openness of the cataloging, which I think is super important, because if you don't have the right information, you cannot tell all the story. Regarding better design of satellite, we have a PhD student working at EPFL trying to rethink the way we're building satellites. And one of the ideas that you kind of see here is to use some pattern languages to develop a satellite and a space mission, with the idea that when you think of your orbit, so that's kind of a description of your satellite being launched and going to, in this case, going to the moon. And of course, you will get rid of the last stage of your rocket and things like that. And you see the different colors. And the idea here is to really think, when you develop your space mission, to think of all the components you're launching in space and what they will do in the future, right? Of course, the thing you want to put on the moon will go to the moon, but what about all the other things that allow this to happen, right? And are they going back to Earth and burn into the atmosphere, or what you do with them? Maybe, depending at the stage of the mission, you can also, put it in an orbit that goes very far away, and then it's fine. But really, the idea to think a bit differently and think about all the stages of your mission. And using these pattern languages is an interesting way, because you can look at different aspects. You can compute the risk, you can compute the mass to LEO, which very closely linked to cost, but you can also do some kind of rating estimate of your space system. Other activities we're doing in terms of research is about developing the technology that would, for example, in the case of clear space, made the capture possible. So capture is about robotics on one side, but it's also about vision and recognition of your satellite that could be rotating. So because you have limited, data transmission, you have to do a lot of onboard computing and image recognition of your satellite. So that's a lot of things that are being developed. you should think also of how you build your satellite so that when you enter back to the atmosphere, it's completely destroyed. So we are looking with the material lab about how you best build a satellite and things like that. And regarding the space sustainability rating, so this is an idea that was started in 26, 28. So UT Texas, MIT, Rice Consulting, ESA, and they develop a way of rating a satellite or mission. This rating, they had an open competition, and we basically compete to implement this rating, and we've been selected. That happened this year, and hopefully starting next year, we'll start to put things in place. Hopefully, oh yeah, sorry, I need to be here for the camera. And then we can basically share this rating to the community. So we currently have some beta tester, some company who are testing the rating, and we're working with them to understand how to put this in place. And hopefully this in the coming months will be effective. And of course, the first garbage truck in space, the Clear Space mission. The goal here is to launch the space mission in 2025. But of course, to reach this goal, there's a lot of things still to be done. Building the satellite, building the robotic arm, building the intelligence behind the system. So that's kind of a race because 2025 is very, very close in time. Okay, and the final point is about communicating and engaging with different actors. And we had a sustainable space logistics digital symposium early this year, and we continue to bring information to the community and share perspective view of each of the partners in this space activity. Right. So, what if we were doing nothing? As Tim was saying, we constantly rely on space. So that's going to be a big challenge if space is not available in the near future, and would have a big impact on human society. So to finish, I just ask yourself, so what are you doing for space sustainability? We really need to think about it in a common way. And I think it's good to have questions and discussion about it. Thank you.
So thank you, everyone, and thank you, Jean-Paul, for this presentation. So if you have questions, it's also time. I also want to remind if there is any live viewer on the internet, you can ask also questions on the chat on the YouTube channel. I will take also a few of them afterwards. So I have one question there. You have a mic coming.
Thank you, Professor, for your wonderful talk. We in India, with guidance of ISRO as a startup community, we ensure that any hardware going to space has sufficient delta V capability to deorbit at the end of life. So that's a step we together are taking. That's a message we would like to give to you. On the other hand, it's a personal question to you as an astrophysicist. Looking at all your observation is land-based. With the telescopes, the 30-meter telescope coming, everything. But with so much of thousands and thousands of satellites going up, how would it affect science?
It's a very good question. I mean, in general, I would say in optical astronomy, the density, or at least today, the density of satellites is not such of a problem. As you see in that big images, I mean, so we have a few, of course, when you have a track, everything below the track, it's like a loss of information, okay? But usually when we do a data acquisition, we have multiple images of the same place in the sky. And so instead of relying, like say, at four images, then we rely only at 3 images at the place where you have the satellite passing. So of course it's a problem because your data quality is not as good, but we can mitigate the problem in the sense that by taking multiple images, we can get rid of the problem. So in optical astronomy, although it's a problem, and but we can deal with and we can mitigate the problem. In radio astronomy, that might be more difficult, and especially when you work at higher frequency, and especially with these very large number of satellite communication. We are building radio telescope on the ground in places where there's very little communication system. So, for example, the SK project will build a telescope in South Africa and Western Australia, where it's a desert land, and there's very little communication because there's no one basically, right? But in fact, there's going to be lots of people, let's say, our communication system with these many constellation of satellites that are trying to provide 5G internet. And this is more an issue because it would be very difficult to have those satellites just avoid passing above the the radio telescope. So for this reason, I think the problem is more critical in radio. So of course, radio, communication is done at specific wavelengths, but if there's so many satellites with their own wavelengths or own frequency of communication, then basically that erases quite a big window in the radio frequency that you cannot observe to observe the sky. So that's more of a problem than the optical astronomy.
Thank you so much. Yeah, thank you for the excellent presentation. Just my question is because nowadays when we are talking about the many satellites, the solution is coming up with very small satellites, CubeSat type of things. But this is more and more debris. That is another problem.
Yeah.
So whether we should go for a small satellites or bigger satellite with the less number of satellites with more sensors, how to go about it? First, this is one question. Another question is regarding your garbage truck. It is really what type of sensors you are putting? It is a attractor type of things, or it is only a robotic arm type of things? Because attractor is then it is much better to have such solutions, I think. Thank you.
Okay, so there's two questions. First one, whether you should design a small or bigger satellite. Well, it's a very good question. I don't have the answer. I think one has to do a study about it. I just don't have the answer. I mean, that's clearly something as a design phase. I think this is something very important to do. What's the best? As the second question, can you repeat me again? Oh, yes. Yeah. Yeah. So at the moment, what we've been developing is something which will just grab the satellite. But I understand effectively you could think of different system. But of course, for debris that are up there for a while that were not designed to be, tracked back to Earth, there's like no magnet or nothing. So they've not been designed to be, attracted, through magnet or whatever. So you have for these old system to have a, grabbing system. I think there's no other way. But effectively for the future, if you think of this constellation, people should be thinking also, if I have that many satellites orbiting, I will deorbit them, either with propulsion or with kind of another type of truck. But then you should try to develop your satellite in such a way that it's easy to be grabbed, basically.
Excuse me, sir. The ground system will be tracking, and the robotic arms in the space will be grabbing. because normally the lidar and these are the new techniques that's coming up. The satellites itself will track the trap even a small 1 centimeter by 1 centimeter also, and that will be that intelligence can be embedded into the tracker, and the tracker will drive the robotic arm and
Yeah,
grab it, because a lot of synchronization,
exactly.
the location parameters have to be synchronized. So what kind of that synchronization, telemetry tracking, etc., are incorporated in your
So
space?
the system we're developing should be autonomous in the sense that we don't rely on observation from the ground. Of course, we rely on observation from the ground to make sure that the orbit is correct, that the satellite may not be rotating too fast. But in terms of the capture, it should be fully autonomous. So there will be a radar system to locate the satellite. There will be lidar system to when you get closer and to measure exactly at the distance, and a camera to recognize the rotation of the satellite if it rotates. And then there will be an automatic grabbing system.
Second is, are you open for discussion? Some of the startups, as is telling in India, they're interested in the debris management, both the tracking and mitigation. Are you interested to open a discussion with them?
Yeah, I think it would be.
We will divert them.
Yeah.
We will divert them.
Yep.
Thank you.
There's a question here. Vincent.
Two questions.
Oh, two.
First is, once you grab the satellite, what are you going to do? Are you going to bring it back or push it to something else? And second question would be, how do you capture a small size of debris? Because are you going to squat them like mosquitoes or something like that?
Yeah, so for this first demonstration satellite mission, the idea to just bring back to the atmosphere and crash everything into the atmosphere. So both the chaser that grabbed the satellite and the satellite, I mean the debris itself. So everything will be hopefully burnt when going through the atmosphere. But of course, if you think of, a real service that could be developed in the future, I mean, that doesn't make sense in the sense that, it would cost too much as a service. And so the future idea, which is not developed for this first mission, is to have a kind of a truck that go and grab your satellite, lower it down to, say 400, 500 kilometer altitude, and then go and fetch another one and do this many times. But there's many different options to be think about it. But that's one of them. Certainly, if you want that the service applies, of course, it will have some robotic arm of some dimension. So that means you cannot also you have to scale your system so that you can capture only some kind of satellite. You cannot, if you want to go for CubeSat, the system should be different than if it's a larger piece of hardware. Sorry about that. So did I understand you? I mean, answer your questions or? Yeah. No. And I guess you probably have to adapt your system depending on the size of your debris.
Very good afternoon, Professor. It was a nice presentation and discussion. My point is, as you mentioned, orbit as a nature, and is there any policy as such we can bring in that every company you told in 2025, nearly your service will start for deorbiting things. So you also mentioned that you will go and ask each and every companies for services. So the question is over here, there is any policy we can have it or is already available? I'm not too sure, but while people launching the satellite or launch vehicles in the system, So they should have as it is an ongoing journey, they should have a return ticket of bringing it back before launching it. So is it possible like that?
Well, ideally, I think it would be great if such a measure is in place. Uh, I guess as of today, there's no such things. Um, but it's also the fact that if you don't have a garbage truck, then your garbage just piling up, right? And you cannot force anyone to have this garbage pile up because there's no garbage collector basically. But if you demonstrate there's a way to clean space, then of course the mindset will change completely, right? Or at least hopefully it will change completely, because then things are possible, and then people have to think differently and have to think of a way, either bringing back by enough propulsion back, allowing your satellite back to Earth, or if it's just impossible, or if you have a failure of your propulsion system, then maybe you could benefit of the service.
It's not a question, it's an opinion. Uh, it's an excellent idea as a demonstration. It definitely will be an inspirational part. I just want to tell you, there are many young boys and girls are really aware of the issues of debris, and they are writing to us because we are in the space domain. I am getting mails from young boys and girls on how to overcome this, and they're given me paper sketches on how a recovery satellite to save debris can be done. But many of them really don't understand the fundamentals of this. It may be okay for one particular debris to be returned by one particular chaser. The energy required in moving from one spacecraft location to another is tremendous.
Yep.
And it requires a huge amount of propulsion capability to move even a little bit of orientation, or we call it the inclination.
Yes.
And also the altitudes and different directions.
Yep.
So to have a general truck that will go around and collect the debris and bring back, it may be a very difficult proposition to start with. At least this idea to demonstrate it is good, but then technologies need to evolve for a long-term return. I fully agree that we need to have an auxiliary propulsion as part of every spacecraft, which at the end of the life of the spacecraft will take on the whole journey, including an inertial system which will come on.
Yep.
It'll propagate the state vectors from the prime mother satellite to this, and then take on the further journey of deorbiting or returning back to Earth. This is the only way for, at least for bigger satellites, to be deorbited. The other means are only evolving, and it is more economical and energy efficient way of handling future debris to come. But what is to be done for the one which are going to the orbit now, the 1,500 numbers per year, we need to be really worried about. Like the ecological disruption that we are doing, it is similar to that we are making it until humanity realizes that it is a very serious issue.
Yes.
The actions may not really come up in big way. But at least your idea and your proposal to have such a launch really inspire. I hope it will inspire the generations. Thank you.
I'm grateful of your comments. I really share your views, and I think effectively, there's a lot to be done, and there's probably a different way to do things. And effectively, one of the issue is changing the inclination of your garbage truck. So maybe you could think of having different garbage truck for different type of inclination. So, the idea is to open basically, a way of thinking differently and propose solution. And I don't think there's only one solution, and we'd be very happy to see other, countries on Flying Nation doing this kind of thinking and sharing their ideas.
We have a question here. Maybe it's the last question.
It's not a question, just an idea about if we were to make it mandatory in every satellite to have certain amount of reserve energy and what we call as a homing point from wherever it might be. Once it hits this reserve energy level, then it has to go to a designated, let's call it as a waste bin, waste paper basket kind of a place. If we make that as a policy that every satellite must have these two put into it, will there be an easier solution? From there on, we need to send the truck only to one point.
Yeah, I mean, certainly if you design your satellite to have, enough energy to bring it to lower orbits, like, 400 kilometers, for example, and then after, a few orbits around the Earth, it will decay and go through the atmosphere. Certainly that's a solution. I guess one of the issue is that, are you really going to, or a service provider, are they really going to use this fuel for just doing that, or just to extend the mission? Okay. But yeah, I mean, certainly that's the way to go. And it's certainly, if every satellite has a propulsion system to allow, re-entry.
Because otherwise, today, every satellite is a one-way ticket. It's up there.
Exactly.
And we need to build that return ticket into it.
Exactly. But of course, you could have also a failure of your propulsion system, right? Or your satellite could be hit by a debris, and then your propulsion system doesn't work anymore. So certainly that's the way forward, but it doesn't probably solve every problem.
Thank you very much for the audience and all those questions and its interest. I think with some of you, we will be able also to continue the conversation. And I also wanted to thank also our viewers online and wish you also a lovely day. I don't know if Dante.
Yes, thank you very much for this fascinating presentation. My name is Dante Darini. I'm project manager here for the Swiss Pavilion. It was an honor to receive you all. Now, I would love to continue the conversation with the speakers and yourselves. So we have to vacate this room. However, we have okay. We have a VIP area which is open if you want to discuss. Ladies and gentlemen, a very good afternoon to you all. My name, as I mentioned before, is Dante. I'm from the Swiss Pavilion, more specifically from an organization called SwissNex, which helps to promote Swiss education, research, innovation abroad and connect them with local equivalents. And today, oh my, we have a treat for you because we're very lucky to have two astronauts who will share more information about what they achieved in space. We have the chance of having Mrs. Naoko Yamasaki, former JAXA astronaut and one of the ambassadors of the Japanese pavilion here. We're also very lucky to have Professor Claude Nicolier from Switzerland, from professor at the EPFL, and also a former Swiss astronaut who's going to be sharing more information about what he achieved through space. So without further ado, I would like to start this session by inviting Ms. Yamakasi to join us and present a bit more about your experience out of space. Ms. Yamasaki, thank you very much.
Hello, ladies and gentlemen. My name is Naoko Yamazaki from Japan. And thank you for the kind introduction, Dante. And first of all, I'd like to express my gratitude to Swiss Pavilion to host this event and Claude for his friendship. And today, I'd like to share my experience in space. And can I click here? Hopefully it starts. Okay. Here we go. So this is the International Space Station, as you can see. And I spent 15 days on board the ISS in 2010. So, and actually, this is my first time in Dubai, but I visited Abu Dhabi before this trip. I attended at World Space Congress, And also I have a lecture in the University. So it was my great honor to visit UAE a couple of times. And probably as you know already, Japan launched UAE's Khalifa-Sat back in 2018. It is an Emirati first developed satellite. And in 2020 from Tanegashima in Japan. So I'm very pleased to see those collaboration between space programs in between countries. And this is in the UAE. Can you see the beautiful lights? And Dubai International Airport from space. Well, so this is the picture of the group picture on board the ISS. We have 13 crew members for total, and 7 were launched in a space shuttle, and 6 were on an expedition